Browser compatibility and transpilation. Introduction. You're probably prompted to update your web browser every few months. Do you know why? A few reasons include addressing security vulnerabilities, adding features, and supporting new HTML, CSS, and JavaScript syntax. The reasons above imply there is a period before a software update is released when there are security vulnerabilities and unsupported language syntax. This lesson focuses on the latter, specifically how developers address the gap between the new JavaScript syntax that they use and the JavaScript syntax that the web browser recognizes. This has become a widespread concern for web developers since ECMA International, the organization responsible for standardizing JavaScript, released a new version of it in 2015 called ECMAScript 2015, commonly referred to as ES6. Note, the 6 refers to the version of JavaScript and is not related to the year it was released. The previous version was ES5. Upon release, web developers quickly adopted the new ES6 syntax, as it improved readability and efficiency. However, ES6 was not supported by most web browsers, so developers ran into browser compatibility issues. In this lesson, you will learn about 2 important tools for addressing browser compatibility issues. CanIUse.com, a website that provides data on web browser compatibility for HTML, CSS, and JavaScript features. You will learn how to use it to look up ES6 feature support. Babel, a JavaScript library that you can use to convert new, unsupported JavaScript, ES6, into an older version, ES5, that is recognized by most modern browsers. Let's get started by running ES6 JavaScript on a fake old web browser version. Instructions. Copy the following code into main.js. The code includes 3 features of ES6 syntax: const, let, and ES6 string interpolation. Run the code when you are ready. Look at the errors displayed in our letscape. Okay, we'll copy all of this and we will paste it right in and press run. There we are. We're working now. Let's move on to the next lesson. CanIUse.com 1. Since ECMA's release of ECMAScript 2015, ES6, software companies have slowly added support for ES6 features and syntax. While most new browser versions support the majority of the ES6 library, there are still a couple sources of compatibility issues. Some users have not updated to the latest ES6 supported web browser version. A few ES6 features, like modules, are still not supported by most web browsers. Because companies add support for ES6 features gradually, it's important for you to know how to look up browser support on feature-by-feature basis. The website CanIUse.com is the best resource for finding browser compatibility information. In CanIUse, you can enter an ES6 feature like let and see the percentage of the browser that recognizes it. You can also see when each major web browser, Chrome, Safari, Edge, added support for the keyword. The video to the right shows you how to get started with CanIUse. So you can go ahead and watch that video to the right. The instructions say, in the video, we will use CanIUse.com to find the percentage of browsers that support the entire ES5 library. Then we will look at the percentage of browsers that support modules, a feature introduced in ES6. So go ahead and play that video back for yourself and then follow me to the next lesson. CanIUse.com 2. Now it's your turn to get some practice with CanIUse.com. In a new tab, open CanIUse.com and complete the task below. Instructions. Look up the percentage of browsers that support JavaScript ES5, save the value as a number to the variable ES5 percentage support. ES5 percentage support, and we need to make that equal to the ES5 support. We see the percentage right here is 98.08. Let's paste that in and run it. Without the %sign. I didn't mean to copy that. Let's run it. That does it for us. Look up the percentage of browsers that support template literals, a feature that was introduced in ES6. Save the value as a number to the variable ES6 template literals. So we're going to look for this term, template literals. I'm going to copy it, go to can I use, put it in there, and let's take a look. Looks like 94.59%. So let's write that in this time. 94.59 and no percentage. We'll run that. Let's go to the next lesson. Why ES6? Before we learn how to set up a JavaScript project that converts ES6 to an older version, it's worth understanding a few of the reasons ECMA made such substantial updates. The version of JavaScript that preceded ES6 is called JavaScript ES5. 3 reasons for the ES5 to ES6 updates are listed below. Readability and economy of code. The new syntax is often easier to understand, more readable, and requires fewer characters to create the same functionality, economy of code. Addresses sources of ES5 bugs. Some ES5 syntax led to common bugs. With ES6, ECMA introduced syntax that mitigates some of the most common pitfalls. A similarity to other programming language. JavaScript ES6 is syntactically more similar to other object-oriented programming languages. This leads to less friction when experienced non-JavaScript developers want to learn JavaScript. Because ES6 addressed the above issues, ECMA knew that adoption by web developers would occur quickly, while web browser support lagged behind. To limit the impact of ES6 browser compatibility issues, ECMA made the new syntax backwards compatible, which means you can map JavaScript ES6 code to ES5. Instructions. In these tasks, you will manually change the code in main.js to ES5 syntax. The let and const keywords were introduced in ES6. Before that, we declared all variables with the var keyword. Change the let and const keyword in main.js to var. Okay, const will be var, let will be var, and let's run it. Oh, we had one more const down here. That's also var. Number 2. The following line of code is written with ES6 string interpolation. In ES5, we used plus signs, plus, to interpolate variables into strings. In main.js, use ES5 string interpolation to set carbonara to the same string as above. Let's see what we have here. We're going to plus to this, and plus to this. We also need these spaces as well, but we could do that by closing off these quotes right here. Then we'll add a space, and we'll get rid of what's around pasta, and we will plus to pasta. Oh, I'm sorry. I got rid of that space by accident. And here we have meat. So we will plus to that. And give it a space, and then to meat. Then plus to another comma with a space in front of it, comma after, plus, and a sauce made with, finish that out, get this tick away, get that tick away, replace it with a normal quote, and we will have a plus to sauce, and we'll need a space there. We might be missing a space somewhere around here, I'm not exactly sure. I think that might be in the wrong spot. It looks like we might be working properly here. Let's give it a run. That did work. We did our ES6 to ES5 from string interpolation to that plus interpolator. We could go on to the next lesson. Here we go. A transpilation with Babel. In the last exercise, you manually converted ES6 code to ES5. Although manual conversion only took you a few minutes, it is unsustainable as the size of the JavaScript file increases. Because ES6 is predictably backwards compatible, a collection of JavaScript programmers developed a JavaScript library called Babel that transpiles ES6 JavaScript to ES5. Transpilation is the process of converting one programming language to another. In the remaining exercises of this lesson, you will learn how to use Babel to transpile the new, easy-to-write version of JavaScript, ES6, to the old, browser-compatible version of JavaScript, ES5. In the instructions below, you will pass JavaScript ES6 code to Babel, which will transpile it to ES5 and write it to a file in the lib directory. Instructions. In the terminal window, type npm install babel-cli. This installs one of the two required Babel packages. npm install babel-cli. And now that's installed. In the terminal window, type npm install babel preset env. I'm just going to copy this in, babel-preset-env. That worked as well. Let's do number 3. In the terminal, type npm run build and press enter. npm run build, enter. You can view the ES5 code in .lib/main.js. You may need to refresh to see the newly created lib directory. All right, let's refresh to get to that directory. Don't quite see that directory here. I would imagine it's kind of in the folder. Oh no, it's right here. Okay. So we have lib. Oh, I see. So here it is. It's going to be var, and here is the interpolation that we did the last time, but it's done for us with Babel. Babel is doing all of this for us. That's what happened there. Let's move on to the next lesson. npm init. In the last exercise, you wrote one command in your terminal to transpile ES6 code to ES5. In the next 5 exercises, you will learn how to set up a JavaScript project that transpiles code when you run npm run build from the root directory of a JavaScript project. The first step is to place your ES6 JavaScript file in a directory called src. From your root directory, the path to the ES6 file is /src/main.js. The initial JavaScript project file structure is project, then src, and then main.js. And they're all within each other. So src is in project, main.js is in src. Before we install Babel, we need to set up our project to use the Node Package Manager. That's npm. Developers use npm to access and manage node packages. Node packages are directories that contain JavaScript code written by other developers. You can use these packages to reduce duplication of work and avoid bugs. Before we can add Babel to our project directory, we need to run npm init. The npm init command creates a package.json file in the root directory. A package.json file contains information about the current JavaScript project. Some of this information includes metadata. This includes a project title, description, authors, and more. A list of node packages required for the project. If another developer wants to run your project, npm looks inside package.json and downloads the packages in this list. key value pairs for command line scripts. You can use npm to run these shorthand scripts to perform some process. In a later exercise, we will add a script that runs Babel and transpiles ES6 to ES5. If you have Node installed on your computer, you can create a package.json file by typing npm init into the terminal. The terminal prompts you to fill in fields for the project's metadata, name, description, etc. You are not required to answer the prompts, though we recommend at minimum you add your own title and description. If you don't want to fill in a field, you can just press enter. npm will leave these fields with default values or leave them empty when it creates the package.json file. After you run npm init, your directory structure should contain the following files and folders. Project, src is inside of project, main.js is inside of src, and a package.json that's just inside of project. npm adds the package.json file to the same level as the src directory. Instructions. Run ls in the terminal to see the file structure of your current directory. ls, enter. We see we have src in there. Use npm to create a new package.json file. We recommend you set the name and description properties to the following values. Name, learning Babel. Description, use Babel to transpile JavaScript ES6 to ES5. So that was npm init. This utility will walk you through creating a package.json file. It only covers the most common items and tries to guess sensible defaults. See npm help JSON for definitive documentation on these fields and exactly what they do. Use npm install package-save afterwards to install a package and save it as a dependency in the package.json file. Press Shift-C at any time to quit. Name. Learn JavaScript Transpilation BCT npm init. We want to change the name to Learning Babel. So let's get rid of all of that. Oh, can we? I don't know if we can get rid of all of that. Well, they're getting us down to version and then description. Well, let me try doing this again. Maybe I accidentally pressed enter. npm init. They seem to have the name figured out. Okay, so let's just put the description in. Call it learning. Oh, that's the name. Entry point ES6 test command didn't give us one of those. There's no Git repository. Keywords, quite a bit here. This is okay. Yes. And we're good. Okay, so we didn't have to put that name in there to pass this part of it, and we did set up that file. Enter ls to take a look at what happened. We have a package.json now. Okay, great. Let's move on to the next lesson. Install Node packages. We use the npm install command to install new Node packages locally. The install command creates a folder called Node Modules and copies the package files to it. The install command also installs all of the dependencies for a given package. To install Babel, we need to npm install two packages, babel-cli and babel-preset-env. However, npm installs over 100 other packages that are dependencies for Babel to run properly. We install Babel with the following two commands, npm install babel-cli, and then -D, npm install babel-preset-env, -D, and that's a space between the name, between babel-cli space and then -C. The babel-cli package includes command line Babel tools, and the Babel preset env package has the code that maps any JavaScript feature ES6 and above, ES6 plus, to ES5. The -D flag instructs npm to add each package to a property called dev dependencies in package.json. Once the project's dependencies are listed in dev dependencies, other developers can run your project without installing each package separately. Instead, they can simply run npm install. It instructs npm to look inside package.json and download all of the packages listed in dev dependencies. Once you npm install packages, you can find the Babel packages and all their dependencies in the node modules folder. The new directory structure contains the following. We have a project, that's the project folder. Inside of it is node modules, src, and package.json. Inside of node modules is a .bin, and then ... meaning a bunch of other folders. Inside of src is the main.js. The ... in the file structure above is a placeholder for 100 plus packages that npm installed. Instructions. Enter ls into the terminal to view the current directory's file structure. ls, enter. We have package.json and the src. So here we have the project, package.json, and src are in there. We don't seem to have node modules. Use npm with the -d flag to install the Babel command line package and add it to the dev dependencies property in package.json. So that was npm install, and there were two of them. So let's do both of them. Here we are, npm install babel-cli and capital D. And now let's do the other one, npm install babel-preset-env -D. Let's see if we did that properly. Okay, yes, we did everything there. So I didn't read this third one. That's done already, but let's look at it real quick. Use npm with the -d flag to install the Babel preset environment package. That's why it happened. I just did that. I did both of them. And add it to the dev dependencies property in package.json. Enter ls into the terminal to see the file structure of your current directory. Notice the addition of node modules. Let's see that real quick, just ls. And now we have node modules, package.json, and src. You can also see the new folder by clicking on the file navigation button above the text editor. So the folder should be in here. There it is, node modules. Let's go to the next lesson. .babelrc. Now that you've downloaded the Babel packages, you need to specify the version of the source JavaScript code. You can specify the initial JavaScript version inside of a file named .babelrc in your root directory. You can run touch.babelrc to create this file. Your project directory contains the following folders and files. Project has node modules. Inside node modules is bin and 100 other modules. It has src, which contains the main.js, and on the first level again has babelrc, and on the first level again it has package.json. Inside babelrc, you need to define the preset for your source JavaScript file. The preset specifies the version of your initial JavaScript file. Usually you want to transpile JavaScript code from ES6 and later ES6 Plus to ES5. From this point on, we will refer to our source code as ES6 Plus because ECMA introduces new syntax with each new version of JavaScript. To specify that we are transpiling code from an ES6 Plus source, we have to add the following JavaScript object into babelrc. And it is an object that says presets as a string and has a env inside of an array as a string as well. When you run Babel, it looks in .babelrc to determine the version of the initial JavaScript file. In this file, env instructs Babel to transpile any code from version ES6 and later. Instructions. In the root directory, use touch to create a new babel.babelrc file. So we want to say touch.babelrc. That did work. Open the .babelrc file and add an object that specifies the preset to env. Okay, let's go up here into the babelrc, an object that specifies preset, and that is lowercase. Yes, it is preset. And it's going to be an array, and then make it a string and put env in there if I'm correct. Let's take a quick look. Yep, this looks just about right. Let's run that. Nope, that's wrong. Did you add presets? Oh, no, I didn't add the S. That was a typo. Now it's right. Great, let's move on to the next one. Babel Source Lib. There's one last step before we can transpile our code. We need to specify a script in package.json that initiates the ES6 Plus to ES5 transpilation. Inside of the package.json file, there is a property named scripts that holds an object for specifying command line shortcuts. It looks like this. And it has scripts in there. It opens up an object and it has tests, which has echo, error, no test specified, and exit 1. I guess exit with exit, error code 1. In the code above, the scripts property contains an object with one property called test. Below the test property, we will add a script that runs Babel like this. So they have their scripts, and after the exit 1 is a build script. And the build script points to babelrc-d lib. In the scripts object above, we add a property called build. The property's value, babelrc-d lib, is a command line method that transpiles ES6 plus code to ES5. Let's consider each argument in the method call. Babel, the Babel command call responsible for transpiling code. src instructs Babel to transpile all JavaScript code inside the src directory. -d instructs Babel to write the transpiled code to a directory. lib, Babel writes the transpiled code to a directory called lib. In the next exercise, we'll run the babelrc-d lib method to transpile our ES6 Plus code. Instructions. In package.json, add a script called build. When run, the build script should use Babel to transpile JavaScript code inside of the src folder and write it to a folder called lib. Don't forget to add a comma after test script. Okay, so we have to go to where test is. That's right here. We'll comma, and now they want a build script. So we will build, and after that, let's see exactly how they did this. They just explained it to us. We know what everything is. So it's build, and the first thing we want to say is Babel, and then the folder, that's the src, and then -d is to write that code into the directory, and lib is where it should be, is actually what it's called. That's the lib, is where it will be written. Let's write that all in here. We'll have Babel src -d lib. I'm going to go down, just check this one more time. src lib. All right, we look good. Let's give it a shot. Great, that is done. Let's move to the next lesson. Build. We're ready to transpile our code. In the last exercise, we wrote the following script in package.json. Build babelrc-d lib. Now we need to call build from the command line to transpile and write ES5 code to a directory called lib. From the command line, we type npm run build. The command above runs the build script in package.json. Babel writes the ES5 code to a file named main.js. It's always the same name as the original file, inside of a folder called lib. The resulting directory structure is, and they explain the directory structure that's already there, except now it has under project an lib, and inside of lib a main.js, just like you have under project an src, and inside of src there's a main.js. Notice the directory contains a new folder named lib, with one file called main.js. The npm run build command will transpile all JavaScript files inside of the src folder. This is helpful as you build larger JavaScript projects. Regardless of the number of JavaScript files, you only need to run one command, npm run build, to transpile all of your code. Instructions. Transpile the ES6 Plus code to lib using the build command. Once you've done this, navigate to the new lib folder and open main.js. Okay, so npm run build was what was said up here. So let's try that out and run it. And we can see the code here. This is the same code from before, so everything should be changed to var, and this should be done with pluses instead of this string interpolation we're doing with the $ and so on. Let's take a look. Into files, we have src and the main. Oh, I didn't run this yet. There we go. Here we go. And we have files lib and another main. So let's check out this other main. Remember what this looks like. This has var pasta, var meat, var sauce, var carbonara, and you can see the pluses are how we string interpolate in this one. Let's move on to the next lesson. Review. In this lesson, you learned about browser compatibility and transpilation. Let's review the key concepts. ES5, the old JavaScript version that is supported by all modern web browsers. ES6, the newer JavaScript version that is not supported by all modern web browsers. The syntax is more readable, similar to other programming languages, and addresses the source of common bugs in ES5. CanIUse.com, a website you can use to look up HTML, CSS, and JavaScript browser compatibility information. Babel, a JavaScript package that transpiles JavaScript ES6 Plus code to ES5. npm init, a terminal command that creates a package.json file. Package.json, a file that contains information about a JavaScript project. npm install, a command that installs node packages. Babel-CLI, a node package that contains command line tools for Babel. Babel-preset-env, a node package that contains ES6 Plus to ES5 syntax mapping information. .babelrc, a file that specifies the version of the JavaScript source code. Build script, a package.json script that you use to transpile ES6 Plus code to ES5. npm run build, a command that runs the build script and transpiles ES6 Plus code to ES5. For future reference, here is a list of the steps needed to set up a project for transpilation. Initialize your project using npm init and create a directory called src. Install Babel dependencies by running npm install babel-cli-d, npm install babel-presets-env-d. Create a babelrc file inside your project and add the following code inside it. It opens up an object, it adds presets, and then it puts in env into an array. Add the following script to your scripts object in package.json. Build babel src -d lib. Run npm run build whenever you want to transpile your code from your src to lib directories. Instructions. If you want some more practice, take a moment to add JavaScript files and ES6 syntax to the src folder and try transpiling them. Once you feel comfortable with this process, try setting up Babel on your own computer, and you can do that as much as you'd like, but I'd like to see what's up next. Let's take a look.